Hello programmers, welcome to another Introduction to Java tutorial. Today we're going to be talking about all things arrays. So first we need to ask ourselves, what are arrays? Well, here's a very simple way to think of arrays. Have you ever wanted to store a bunch of different, let's say, integer values? Let's say you needed to keep track of a ton of different numbers. You needed to remember 9 and 5 and 2 and 3 and 4, and then put those all into your program. Well, one way we could do this is by writing a ton of different integer variables and having different separate variables and then keeping track and updating those variables individually, but that's a lot of work. So programmers have made things a bit easier on us by creating these things called arrays. And arrays are essentially lists, and they allow us to keep track of a bunch of data and different types of data and then manipulate them, all in the same place. So without further ado, let's learn about arrays. As you can see, I've already opened up my IDE, and I've already created a class called myArrays and given it a main method. Now, let's learn the syntax for declaring a regular old array. So if I want to create an array of integers, which just keeps track of a bunch of integers, what I need to do is first specify the type of the array, which is going to be an integer type array, and then to show that this is not, that we are not in fact declaring an integer variable, but instead declaring an integer array, I have to put these two brackets in, and then I need to make a name. So I'm going to call it my int array. As you can see, this is very similar to how we would be declaring an object or a variable. And then we can do two things after this equals right here. So the first thing we can do is we can just construct a new array. So we write new and then int, and we put a semicolon here, and within these two brackets we're going to need to specify the length of our array. So you can think of an array as a list with a specific amount of slots. So the slots actually start at slot 0, and they would only go up to slot 5 because we've created an array with 6 slots. So if we start at 0, we're not going to have a slot 6. Let's write that out real quick. So we start with slot 0, 1, 2, 3, 4, 5. As you can see, this right here is 6 lines of code, meaning that these are 6 slots right here. As you can see, we don't have a slot 6, but we do have a slot 0. So just keep that in mind when you're trying to access different spots in your array. You don't actually have this number as an available slot, because we start at 0 and not 1 as we would if we were just counting. So now that we know how to set up an array in this manner, let's talk about accessing these different slots, and how do we put values into these slots, and how do we change those values, and how do we access those values. Well, it's actually very easy. All we have to do is type the name of our array, myInt array, and then we put these two brackets in, and let's say we wanted to put the number 0 into slot 5. Well, in that case, what I need to do is I need to specify that I'm talking about slot 5. So I'm going to put a 5 into these brackets, and keep in mind slot 5 is our very last slot in this array. And then we're going to say equals, and then I believe I said we're putting a 5 in there, so we're going to give that value a 5. Another thing we could do is, what if we wanted to retrieve a value from slot 5? Well, in that case, if we wanted to print that value to the console, we could just type system.out.print line, and then we type myInt array 5. And just like that, the computer knows to retrieve whatever value is stored in slot 5 of myInt array, and right here the computer knows to assign a value of 5 to slot 5 of myInt array. So if we run, we should see that we print out 5. Easy enough. Now let's talk about another type of array. This is called a two-dimensional array. It's a bit more complicated than a one-dimensional array, but don't worry, we'll get through it. So imagine you have a chart, and charts have both rows and columns, and each of these rows, each of these spots within the rows and columns makes up a slot. So this is how a two-dimensional array functions. It's very similar to a one-dimensional array, but imagine the two-dimensional array as being a bunch of different one-dimensional arrays that combined make up a chart, essentially. So we've got columns and rows. It sounds a bit complex, but once you see the syntax, it'll all make sense. So, in order to declare a two-dimensional array, let's just stick with integer type for now. We're going to need to declare the type, so int, and then we use two brackets because it's a two-dimensional array. One specifying our row that we're talking about, and one specifying our column. See, it works very much like a chart. All right, next we need to write a name. So I'm going to call it my two-dimensional array. That's a long name, I know. And then what we can do is we can do the same thing that we did up here. We can write new int, and then we need to make two more brackets, and then we need to specify the length. So the first of these brackets specifies rows, and the second specifies. The first of these brackets specifies row, and the second of these brackets specifies the column that we're talking about. So let's say I want 3 rows and 3 columns. Why not? Similarly to with our single dimensional array, if we would like to assign a value to a specific slot in our two-dimensional array, all we need to do is write out the name of our array. So my two-dimensional array, I'm going to copy paste that because I don't want to retype it. And then we're going to use 2 brackets. And now let's say we're talking about row 2. So we can put a 2 inside these brackets. And we want to talk about column 2. We can put a 2 here. And then we can say equals 2. Why not? And then we can system.out.println 2 just to make sure that we have successfully assigned a value. And would you look at that? It worked. Now, as I mentioned earlier, this is one of the 2 ways to create a new array. There is a second way, and this second way is useful if you know what values you want to put into the array right off the bat. So if you know you want an array that contains a 2, a 5, and a 7, and you don't need any additional slots, you know those are the exact values you want, then you can do the following. Instead of just assigning each of those slots individually, we can use these types of brackets and write 2, 5, 7. So this will, and of course put that semicolon in the back, this will set up a myInt array to have 3 slots, and those slot 0 will contain 2, slot 1 will contain 5, and slot 2 will contain 7. Similarly, with the two-dimensional array, we can go down here, and we can do almost the same thing, except for you use these brackets. You use as many of these as you have rows. So let's say I have 3 rows in this two-dimensional array. This is row 1. I'm going to make it 1, 1, 1. Sorry, this is row 0. This is row 1. So let's just keep with ones. So 1, 1, 1. And this would be row 2. I'm going to go and just put a bunch of 1s in here again. And then, of course, put that semicolon in there. Okay, so we have successfully set up each of these rows, yet the compiler is still not happy. Why is that? Because we've forgotten a very important thing when writing two-dimensional arrays and setting them up with initial values. We need to put some brackets around the entire set of data, just like that. So, things to keep in mind. Number 1, we've got these outermost brackets. Number 2, every row gets its own set of brackets. And number 3, we put commas between each of the rows. And just like that, we have set up a two-dimensional array with initial values. Now let's talk about the third type of array that we want to work with today. And that is called the array list. Now the special thing about the array list is that it is more dynamic than the other 2 arrays we've talked about today. What does more dynamic mean? Well, more dynamic means it's adaptable. It's to some extent perhaps more useful. These 2 types of arrays are very rigid. If we want to add additional values beyond the length of this array, like if we want to add a 4th slot and a 5th slot, that can become very challenging and in some cases can in some cases be impossible. So with ArrayLists, that's actually not the case. Let's go ahead and learn the syntax for an array list. So in order to create an array list, we're going to type array list because this is a class. And then we need to specify the type of array list that we are creating. Now in our case, since we are dealing with an array list and not a regular old array, we can't use primitive data types like int or double. We have to use classes as the type of the array list. So luckily for us, the smart programmers who developed ArrayLists also gave us some classes that we could use that behave similarly to int, but that the ArrayList can handle. So if we want to continue on working with integers, what we'll need to do is we'll need to use a class called integer, and then we'll call it my array list equals new array list, and then integer, because we got to keep specifying that type, and then open parenthesis, close parenthesis, and semicolon. Now you'll notice that the compiler is still not quite happy with me. That's because ArrayList is its own class, so we're going to need to import the ArrayList class at the very top of our program. So we'll need a statement that says import java.util.ArrayList semicolon. That should do the trick. We have now successfully created a new array list. So let's learn how to use ArrayList. Well, there's some cool methods with this particular type of array that we can work with. So this array list has no values inside of it. If we want to add values to this list, what we can do is we can use the name of the array list and then type dot and use a method called add. What this will do is it will add whatever value we put in here at the very end of our array list. Now, there's different versions of add. For example, there's one with 2 parameters, so we could activate that one by typing in, once again, the title of our array list, and then using the add with 2 arguments. Now, this add method will accept one argument, being the actual value you'd like to insert into the array, and the second argument being a position after which, a slot in the array after which you'd like to insert said value. So let's say I had an array that had a bunch of values in it, like it had a 2 and a 5 and a 10, and I wanted to add right between that 5 and the 10. In that case, I'd figure out what slot 5 was, and then I'd put that in as the second argument, and this would allow me to insert the 5 between those 2 values. Additionally, there are other methods with array lists. For example, dot get will allow us to retrieve a value if we put in the index or the slot number, essentially. And then we can also do dot set, which takes 2 specific arguments, the index and the element. So the index, what slot are we setting, or what slot are we manipulating, and then what do we want to set that slot to? So this will replace values in specific slots. And then another very important one for ArrayList is my ArrayList.size. And this will tell us the length of our array, or how many slots we have in our array. So now that we've learned some important methods concerning our array list, let's go ahead and learn how to print out every single value inside our array list. In order to do this, we're first going to need to put some values into our array list. So let's just put a bunch of adds in, and let's say 2, and let's put another one in and say 3. Another one that says 8, because why not? And now we will learn about the third type of loop that we avoided talking about in our loops tutorial because we didn't know anything about arrays yet. But now that we have learned about arrays, we can go ahead and implement this type of loop. This is called the enhanced for loop. And basically, the enhanced for loop accesses every single element within an array, and then will complete a set of instructions with the value of that slot, if you want that slot to for example, be printed, we could use an enhanced for loop to do that. So enhanced for loops are neat because they spare us a lot of time and effort when we're writing loops for arrays. So let's start by writing an enhanced for loop for this array right here. The syntax for an enhanced for loop goes like so. So what we need to do, actually we're going to need to change this value right here because the array that we declared doesn't actually have 5 slots. So let's change this to slot 2. That should be legal. This as well. And let's just make sure we don't have any other errors in here. Yep, everything compiles. Okay, so now let's write our enhanced for loop. So let's talk about the syntax of an enhanced for loop. In order to create an enhanced for loop, we'll first need to write for, and then we'll need to declare in a variable of the same type as the type of our array. So since we're dealing with an integer type array, we need to declare an integer variable. I'm going to call it x. And then we're going to put a colon here, and we're going to list the name of the array that we are going to run through. So I'm going to call it my int array. And then I'm going to put a open parenthesis, close parenthesis, and a system.out.println x. So what exactly does this do? Well, it's pretty simple. Basically, the enhanced for loop is capable of going through every single slot in an array, and it will take whatever value is in the slot that it is currently working with, and it will place it into x. So let's say our enhanced for loop just started. So it's just started. It sees that in slot 0, it has a value of 2. It'll take 2 and say x equals 2. And then when we print out x, it will print 2. Next, the for loop will come back up here, and it will move to the next slot and say, okay, well, in this slot, I have a 5. So x equals 5, and then it'll print out that 5. And then it will go to the 7 and do the same thing. So when we print, what we should see is that we print every single value of our array. And the reason why we don't see a 7 when we're printing these out is because over here we reassigned the slot 2 to have the value of 5, and this will be slot 2. So this is reassigned to have a value of 5. So really we're dealing with a 255, and you can see that right here, which is right here. This is our preceding print statement. To clear some confusion, let's get rid of that. And let's get rid of the print statement down here, just so that we are only printing our enhanced for loop for clarity's sake. And just like that, we've printed our 255. Now let's get rid of our enhanced for loop for this one-dimensional array. And let's go down here to our 2D array. How would we write an enhanced for loop for our 2D array? It's a bit more complex because we have both rows and columns, but it's still not too hard. So in order to use a enhanced for loop to print out every value in a 2D array, we're actually going to need 2 enhanced for loops that are nested inside each other. This kind of setup is called nested loops, which is kind of self-explanatory. But without further ado, let's learn how to write these nested enhanced for loops. So in order to write the outer loop, which will run through each of our rows, what we're going to need to do is write for, and then we're going to declare an array, actually, of the same type as our 2D array. So we're going to declare int array x and then colon, and then my 2-dimensional array. I'm lazy, so I'm going to copy paste that in. There we go. And we can do open bracket, closing bracket, just like that. Now, some of you might be wondering, why didn't I just write x? Did I just make a mistake? Did I mean to write this? No. Actually, I want to write array of type int, because each one of these rows is in and of itself an array. So you can think of a 2-dimensional array as an array of arrays. So one row might be an array of integers, the second row is an array of integers, and the third row is an array of integers, which means that the overall array, the 2-dimensional array, is in fact an array comprised of smaller arrays. So each of these rows is going to be an integer array, and this is why I set the type to be int array. And then for this inside loop, we're going to go through each of the columns. So we're going to go through each of the values inside the individual arrays. So for this, I'd type 4, and then these would just be integers. So int y, and then my two-dimensional array, and then open bracket and closing bracket. So we're not going to put my two-dimensional array in here. We're actually going to put x. Silly me. So the reason for this is because when we run through this outer enhanced for loop, what's going to happen is the loop will put whatever row we're dealing with into a value of x. So the x is in and of itself an array. So when we're writing the second enhanced for loop, we want x to be the array that we are dealing with, not the two-dimensional array. Don't make that mistake, guys. Avoid doing what I just did. So what we're going to need to do is say that x is the array we're dealing with. So because x represents the row that we're dealing with. And so this setup should allow us to loop through every row and every column of each row. So now if we type in system.out.println, and then how about we put in y, this should do the trick. We should print out a whole bunch of ones. There we go. And 1, 2, because of course we replaced that last value with a 2. And so let's talk about this syntax one more time, just to recap, make sure everybody understands everything. Okay, so we have this outer array, and this outer array is an enhanced for loop. And what it does is it takes my two-dimensional array, which is a two-dimensional array, so an array of different arrays, and it will take the first row, which is in and of itself an array, and it will say x equals this first row, right? And then it will move on to this inner array, and then it'll say, for every value in this first row, go ahead and put that value into y, and then do whatever this set of instructions is, and then move on to the next element, and the next element, and so forth. So this inner one will loop through everything inside a row, and this outer one will loop through each of the rows. And that is how we successfully write a enhanced for loop for a two-dimensional array. Writing enhanced for loops for our array list is even simpler than for the 2D array. We go back to just using one enhanced for loop. And so I'm just gonna copy that so we don't have to retype all of it. And then since we are dealing with integers, we can just type in my array list, just like that. Let's go up here and delete this to avoid confusion later on. And let's print. And boom, just like that, we have printed out every value in the array list. So that's simple enough. But here's one of the flaws with the enhanced for loop. When you're using an enhanced for loop, unfortunately, the enhanced for loop is not able to change values within an array. So let's say we wanted to change the value in our first slot, which would just so happen to be this one right here. This would be slot 0, this would be slot 1. So if we wanted to change the value inside our first slot, we couldn't just write my ArrayList.set and then set that first slot to have a value of, like, let's say 80. That wouldn't work, because since we're putting every value from the array list into this y and only printing out y, changing y won't actually change the array list. So just keep that in mind. When we're using an enhanced for loop, we can't manipulate the array. We can only access its data. We cannot mutate it. But there is a way to mutate data when running and looping through the elements within an array. And in order to do this, we just use a regular old for loop. So let's go back up to our original array. And let's say we want to do what we just did with the enhanced for loop again, but we want to do it with regular old for loops. In that case, what we need to do is we'd use the following syntax. So we'd type for, and then int I equals 0, and I is less than, and then we type the name of our array, my int array dot length. what did I just do here with myIntArray.length? Well, length is an attribute of myIntArray. Basically, every array has a length. As you can see, this array has a length of 3. So by typing this in to our for loop, we have successfully accessed that attribute, and this will retrieve the length of myIntArray, allowing the loop to run through the entire array. And this syntax right here would work for an array of any length. So if this were an array with a length of 20, this would return 20. If this were an array with a length of 2, it would return 2. This is pretty universal, and this is the reason why programmers prefer to use this instead of just writing something like 3, because there are 3 values here. So just keep that in mind. We usually like to write the name of our array, myIntArray.length. And then last but not least, we need to iterate I. I put 2 n's in length. There we go. I++. And now we can type something like system.out.println and then myIntArray I. Let's talk about this syntax real quick. So how does this work? Well, we create a for loop, and we set the variable of the for loop to equal 0, and then we're saying while the variable is less than the length of the array, we want I to advance, and we want the following to happen. So let's just run through each run of this loop. So our variable starts out with 0. 0 is less than the length, which happens to be 3. And so it's going to go into this line of code here and say system.out.print myIntArray 0. So what is the value in slot 0? Well, that just so happens to be 2. Remember that with arrays, our slots start at 0 and go up through 1 minus the length of the array. So next up, it's going to come over here. It's going to say, well, let's add 1 to I, and it's going to say, okay, now I equals 2. Well, 2 is still less than the length of the array, which is 3, so 2 is less than 3. So let's do this again. So it comes down here to the print statement and says, okay, what is the value inside slot 2? I believe we skipped 1, but bear with me. I believe we all understand where we're going with this. So basically, the array will continue to jump through each of these elements and print them. And with this type of setup, we can go ahead and say myIntArray of I equals 0. And what would happen if we were to put this before the print statement, what we should see is that for every element, we are setting the value to 0, and then we're printing out that element. So we should see a bunch of zeros get printed, just like that. So now let's talk about using just regular old for loops to access all of the data inside of a two-dimensional array. As you might have guessed, we're going to need to nest these for loops within one another. We'll need one to access the rows of the two-dimensional array, and one to access the columns. So I've already written out the syntax for this for these nested for loops, but let's go ahead and review it. So we set up our outer for loop to run through each of the rows of the two-dimensional array. We created a variable called int I, and what we're going to do is we're going to say, well, I is less than two-dimensional array.length. When we do two-dimensional array.length, what we're retrieving is the number of rows. So this is going to return 3 because we have 3 rows. And then it's going to say I++ after it's executed this sequence of instructions. And then let's go to the inner array, or sorry, the inner for loop. We have 4, and then we set up a variable called p. And while p is less than my two-dimensional array I.length, what is this right here? Well, this is basically saying instead of looking for how many rows there are, look how many columns there are within a particular row. So while we're executing this array, it would determine what the value of I is. So let's say I is still 0. It would go to my two-dimensional array I, which just so happens to be this first row right here. And it would say the length of this row is 3. And so while p is less than 3, execute the code in here. And these work exactly the same as regular for loops. The only special little tricks occur with these statements right here with the two-dimensional array of I dot length and then the two-dimensional array dot length. So inside of both of our arrays, let's put something like system dot out dot print line and then my two-dimensional array, and then we're going to need to put values into these brackets. And what values would we put in these brackets? Well, since our first bracket represents the row, we're going to need to put I in because I is looping through our rows. And since our second bracket represents the columns, we'll need to put P in because P represents our columns inside our array. We're going to delete that parenthesis right there because we had one too many. And once we go ahead and run this, we should see that it prints out every single element inside our two-dimensional array. Isn't that neat? Now let's go down to our array list. Looping through our array list with a regular old for loop is pretty similar. So what we're going to need to do is we're going to need to type out for. Of course, we need to create that variable, int I equals 0. I is less than, type the name of the array list, so my array list dot, and then we use a method of array list. Instead of just writing dot length, we need to use a method called size. And this method is an accessor method which returns the size of the array list. And because array lists are so dynamic, we need to use this method because it will keep track of any changes. So if we were to increase the size of our array list, dot size would increase accordingly. So we have successfully created this comparison statement. Next, let's iterate I, so I++, and let's put it in our brackets. And now we have the syntax for our for loop going through every element in the array list. Now let's print out every element in the array list. So once again, we'll use system.out.println, and then we use the method I talked about earlier called get. So my array list.get, and then we're just going to set the index that we're working with to I. That should do the trick. Don't forget that semicolon at the very end. And now what we should see is when we run this program, we will print out every element inside our array list. Well, that brings us to the end of our lesson for today. Now we have learned about regular old arrays, two-dimensional arrays, and array lists, how to use enhanced for loops, and how to use regular for loops to access data within each of these arrays. Thank you for watching, and I wish you luck with your programming endeavors.